K.6, add, subtract, multiply, and divide complex numbers. Basically, this is just a review of everything that we've learned so far. Let's see if we've remembered anything. So on this one it says simplify. And when it says simplify, there's a plus sign between both i's. And this is a 1i right here. So they are like terms, so we're going to add them. So negative 9 plus 1 is negative 8, and we put an I at the end, and then we're finished. Basically the same thing, but we're subtracting here. There's a 1 here and a 1 here, and 1 minus 1 is 0. 0i. Please don't put 0i. Just put 0. On these we are dividing, and when we're dividing, that means that there's an I on the bottom. We're not allowed to keep an I on the bottom. Remember, because there's just this part with an I and not two parts with an I on this one, because this is a negative, we're just going to multiply everything by a positive I. And when we do that, we're going to take that I to both tops. We're going to take this I to that bottom. So negative 3 times I is negative 3i. 5i times I is 5i squared. Negative 5i, that's on bottom, times I is negative 5i squared. Now what does I squared do to the positive 5? It makes it negative. What does I squared do to the bottom negative 5? It makes it positive. And then remember, we want to separate these. So this is a negative 3i over 5. That does not reduce. Nothing goes into 3 and 5. And then negative 5 over 5 with no i's, but 5 over 5 does reduce. To a 1. 5 over 5 is the same thing as 1. This is your real number, so we're going to write it first. This is your imaginary number, so we're going to write it second. Okay. On this, remember how to get rid of the I on bottom? We're going to multiply by the bottom's conjugate. So 1 minus 3i, whatever we do to the bottom, we have to do to the top. Remember, the tops are not conjugates, so we are going to do every first, outside, inside, last. But the bottoms are conjugates because we made them conjugates, so we don't have to do the outer or the inner. We could just do the first and the last. Different. So 2 to 2 are all those. There you go. And then first and last. That's basically what you do every single time. So 2 times 1 is 2. 2 times negative 3i is negative 6i. Negative 3i times 1 is negative 3i. Negative 3 times negative 3 is a positive 9. But then there is I squared that we'll take care of in just a little bit. On the bottom, 1 times 1 is 1. 3 times negative 3 is negative 9. But don't forget there's an I squared that we're going to take care of. This I squared changes that positive 9 to a negative. This I squared changes the negative 9 to a positive 9. So then, real number, I have to change colors. Real number to real number, which is negative. Imaginary to imaginary, real to real. 2 minus 9 is negative 7 over 10, because that's a plus and that right there. Negative 6 and a negative 3 on top is negative 9i over 10. The 7 over 10 does not reduce, the 9 over 10 does not reduce, so that would be your answer. Okay. Now, if I was mean about this, I would just tell you that you have to do all of it, because usually that's what you have to do. But look at both parts. What can you tell me about both parts? The first real number is negative, right? And the second real number is negative. Both of them are negative 8s. Those didn't change. But what did change? The imaginary number, one was a positive 6, the other's a negative 6. They are, erase. Just a second, it's going to start messing up on me. I've got to find a better system. These are conjugates. Okay, so if they're conjugates, you don't have to do all of it. You can just do the first to the first and the last to the last and simplify. Negative 8 times negative 8 is 64. 6 times negative 6 is negative 36, but both of them have I, so it's I squared. The I squares are going to cancel out, and that's going to make it a positive. And 64 plus 36 is 100, and you're finished. This negative on the outside is going to go to both of them. So a negative with a negative 6 makes a positive 6. A negative with a negative 9 makes a positive 9. This negative is going to go to both of them. Negative to a negative is a positive. A negative to a negative is a positive. Real numbers, 9 plus 2 is 11. Imaginary numbers, 6 plus 9 is 15. 15i, that is. Okay. And then this one. Let's see if these work again. I like them. This looks really, really bad because of everything that is going on, but there's not a plus sign. There's not a minus sign. There's negatives, but that's okay. So what I'm saying is, this whole thing is one term. This whole thing is one term. So we're going to multiply every individual part with its buddy and then try to simplify it after that. So what I'm saying is, I have a negative times a negative. What's a negative times a negative? A positive. I'm going to put a plus sign right there. Usually I wouldn't want you to, but I'm just going to put a plus sign just so you can see that I've done the negative times the negative. Okay, there's a 2 on the outside. Is there anything on the outside of the other part? Kinda. A 1. So 2 times 1 is 2. Then you have an I on the outside, and you have an I on the outside. So I times I is I squared. We're going to take care of that in a little bit. And then we have square root of 3 times the square root of 3. Whenever you're multiplying radicals together, they don't have to be alike. But if you have a number on the inside and a number on the inside and you're multiplying, you can multiply them every single time. It doesn't matter if they're the same number or not. On this case, it is the same number. So what's 3 times 3? 9. Okay. So I've done all of the multiplying. Now we're just going to fix it up. I'm going to lose the positive because there's no reason why you should put a plus sign in front of anything that is positive. And then there's the 2. And I squared. I squared is negative 1. And the square root of 9 is 3. 2 times negative 1 times 3 is negative 6. I think that's it.